Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Our phone tutors are here until 5:30. If you need some help with your math in Bakersfield, give us a call at 636-4357. San Luis Obispo and the outlying areas, you can call us toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And you can watch us on social media, Facebook, Instagram, Twitter, and YouTube.
Yeah, all sorts of things.
Yes.
And I know Associate Producer Mackenzie is in charge of all of those things and constantly is updating those things and exactly what all of them do. I'm sure you and I are like a little bit behind the curve on that one, maybe. But that's why we've got Mackenzie doing
That's
all
right.
of that. Anyway, we do have a 6th grade call-in contest going on during the month of January. Anybody can call in to do the math anytime they want, as many times as they want. However, during this month, if you're a 6th grade student, let us know your teacher that you have for math. It could be your homeroom teacher or another one that you maybe go to another classroom for. The classroom that calls in the most, we will come out and we will go to your classroom. You guys will be part of a Do the Math program. Every student in the class will win something. The kids that call the most will win more and bigger items.
Good.
And you don't have to do your math that day.
Your regular math.
Right. Well, you might. The teacher may still say, oh, once they leave, we're still going to do the math. But we're going to come out and do some different activities with you and things like that. So that is for this month. We have the 6th grade call-in contest. Last look, we had Berkshire. There was a class at Berkshire and a classroom at Lum.
Oh.
Those are the schools that I think are in the lead right now. So Berkshire and Lum kind of in the lead, but it's still wide open. You have today, and then we still have 2 more weeks after this. So we'll see who comes out on top on that one. Before we get to our first phone call of the afternoon and our 2 very special guests in the studio, let's first take a look at today's Math in the News. All right, today's Math in the News, we'll start off with something that was very current. Last night, the State of the Union.
Yes.
Did you get back in town in time to watch
Saw
any?
about saw the last half of it and then saw some of the highlights.
So some of the highlights.
Yes.
Okay. I think it was a little bit over an hour.
I think it was 59 minutes is what I heard.
Oh, it was? All right.
Yeah, just
Well, because I didn't see the very beginning of it, and I was going on based on when it ended.
Yeah.
So anyway, the State of the Union, and so this is President Obama's final State of the Union. So full gear now, as it has been, and will kick in even more with the election coming up.
Oh, yeah.
All right, with all of the candidates and things like that. But what they do is they kind of look at the states that they project to win and to take. And a lot of students may not, but a swing state.
Right.
Okay. And a swing state kind of they're like, well, you know, if they get this, it'll kind of propel them into, you know, some other states. And this one maybe was projected to go one way, went a different way.
Yes.
So with all of that going on, I saw this graphic in the newspaper and I'm like, I've got to do something with this here. So it's a true swing state. So we can see that Montana has the widest range of temperature extremes, 187 degrees.
Really?
So I was like, all right, let's take a look at this a little bit. Now down here we can see its record high is 117 degrees, set in Glenville in 1893. The record low of -70.
Wow.
-70. I can't. I mean,
I can't imagine.
I grew up in
minus-
New York and it seemed like cold never bothered us, and it could have been 0, -10, and it was just one of those things. But -70 just sounds.
No, I grew up in California, and cold didn't bother me either because it never gets that cold here.
Right.
I can't imagine -70.
Well, and then the 117. I mean, living in Bakersfield and in the valley, it gets pretty hot, but 117. I mean, they're both miserable. So I was like, all right, well, that'll be our news. Now, how will we apply math to this? Well, there are some problems that they have in math books quite frequently that look like the one that we have on the screen right here. So we have 1,025 meters above sea level and 155 meters below sea level.
Right.
So a question often in the book is, what altogether, how many meters altogether from the below sea level
Right.
to above sea level at that peak on the mountain? What do you think some students will do when they look at this, though?
Well, they see 1,025 and they see -155. So if they put those together, most of the time they're going to subtract 155.
Right.
From the,
Which is why
1,025.
870 meters is the first answer that is usually on a standardized test. But what they want to know is the total number of meters, so you add them both together. So I figured that was something that we could start off with, and simply what these are, integers.
Right.
So we just take a look at negative and positive integers. They're whole numbers on the number line, not including the fractions in between. And then we can see the opposites they have listed here is 4 and -4. So integers are things that a lot of students get used to working with. I'm going to have to say probably 4th grade when they're adding and subtracting integers and then multiplying, dividing them, and things like that. And then they'll start doing them again in 5th grade, 6th grade, and then they just keep on doing them until they
Right.
can master them.
And especially in pre-algebra and algebra, when they start working with equations, they have to be able to
Right.
do those operations. Right.
Exactly. And as a matter of fact, I think one of our student guests today, Samantha, will be working with a little bit of those
Right.
later on as well. But I went ahead and put some different examples up there of working with integers and simply adding and subtracting them. Okay, so 12 plus a -9 would be the same as 12 minus 9. And I tried to get as many different situations, let's say,
Combinations,
that we
right.
could put in here. So we
Right.
have now a -4 plus 11. It's simply the same as 11 plus a -4, if you wanted to look at it that way, the same as the first one. Then we have a -2 plus a -16. So they're both the same sign. They're both negatives. So we're adding negatives, so we're going to get a larger negative number.
Right. So you have on the number line. So on the number line, they both go in the same direction. They both go negative. So the answer has to be negative.
Right.
And here's a case where two negatives don't make a positive.
When you multiply them,
Right.
and that is the thing that throws the students off, because they'll put, well, I'm going to put positive 18 because negative and negative is
Negative is
positive. Well,
right.
that's when you multiply and divide.
And that's why the number line really helps when we're doing these.
And it's why practice. And then I know there are some times, I think Mary Lou or Marty, one time I think was the first one, I think that on the program, had, all right, let's make a table, all the negative numbers, all the positive numbers, just add them all up, whichever one has the greater sum. We
Right.
take the sign of that one and find the difference. So anyway, there are just some other examples down there of working with integers, adding and subtracting them, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, if you're a 6th grade student, we have a 6th grade call-in contest going on, and if you're a student in San Luis Obispo County, you phone in and we do one of your math problems, you automatically win yourself ice cream, courtesy of our friends at Doc Bernstein's Ice Cream Lab. And it is the new year. We're almost towards, well, we're in the middle of January. We'll end programming in about 2 months, mid-March. And I know that Docs will have a special flavor set for Do the Math as we get closer to that time. Anyway, we'll go to the phones right now. Our first phone caller from Tevis. Kushi, how are you today?
Hi, how are you?
Good. Great. You're in 8th grade now?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. So I have 3 questions, but it's all in one whole information table.
Okay.
So this is the information I have. It says a swimmer climbs a ladder for 2 seconds to a waterslide that is 5 feet high. He sits for 2 seconds at the top of the slide and then slides 8 feet down the slide into the water in 2 seconds. She stayed steady at the same position underwater for 2 seconds before rising to the surface of the water in 1 second. She remained in the pool for 1 more second. You want me to repeat that?
Well, yeah, I got some of it. Let's see. The student climbs up the ladder, and the ladder's 5 feet high.
Yeah, they're 5 feet high. She's 5 feet high, and she got up there for 2 seconds.
In 2 seconds, okay. Okay, then slides down the ladder 8 feet down and also takes 2 seconds?
In 2 seconds, yes.
Okay.
Into the water in 2 seconds.
And then she's in the water for 2 seconds, is that right?
Yes, before rising to the surface
Then
in 1 second.
Goes up for 1 second and then stays in the water for 1 more second. I think I got all of those seconds in the
Yes.
water. 2 seconds, 1 second, and 1 second. Okay?
Mm-hmm.
And that's all
And
the
then-
information, right?
And she remained in the pool for 1 second, but I think you got that.
I think I got that at the very end. Okay.
Yes. And it says A, B, and C. It says A, what was the average rate of change for the swimmer going up the ladder? And B, at what interval of time is the slope negative? And C, determine when the slope is 0.
Okay, so the average rate of change going up the ladder? Is that what it said?
Going up the ladder.
Okay, so A is find the average rate of change going up the ladder.
Yes,
right?
for the swimmer going up the ladder.
Okay. And B is find the.
At
Okay. Oh, I'm sorry. At what interval?
of time is the slope negative.
What interval of time is the slope
Negative.
negative? Okay. And the last one, C, was
C was determine when the slope is 0.
when is the slope 0? When is slope 0? Okay. So, what do they mean by the average rate of change up the ladder? That's up.
So I think that it's how long it took her to go up the ladder probably and how much time it took her.
Yeah, so the rate of change is like how fast, right? She's changing from 0 to 5 feet going up, right? So she's moving up 5 feet, and the rate is, well, the rate is the speed, isn't it? How many feet per second? So she's going 5 feet in 2 seconds, right?
5 feet. In
So
2
if we want
seconds.
the rate of change up the ladder, so A, the rate of change is 5 feet in 2 seconds, isn't it?
Yes.
So what's 5 divided by 2?
5 divided by 2?
Yeah. So
5.
so we know this is going to be
like
5 halves, right? So what's 5 divided by 2?
2.5.
So that's going to be 2.5, and the rate of change is how many feet per second, right? So she's changing how high she is every second, so it's going to be feet per second. How's that? Instead of miles per hour like a car, the rate of a car, the speed is in miles per hour. This person is climbing up the ladder, and we're going to measure her rate of change in feet per second. So does that make sense?
Yes.
Rate of change, for every second, she's going to change 2.5 feet.
Okay.
Okay?
Can't you make a table though?
So make a table, you mean like it for every second, is like 1 second and then 2 seconds?
Yeah, like because we're doing slope right now, so don't you have to make a table something like that? Like to
Well, for
organize
this,
the
they're gonna ask for the slope of the ladder, right? The slope, the slope of the slide. But for the rate of change, I think all that they want you to find is is how fast they're going up. There's no slope involved in this ladder. I think it's just straight up the ladder, isn't it?
Oh,
Okay.
that makes sense.
So I think rate of change is just asking about how fast the person is climbing the ladder.
Oh,
Now the second one says, what interval of time is the slope negative? So we're talking about slope. And then we're going to ask when the slope is 0. And in the slope is 0, is there a picture for your problem?
yeah, there's like a small graph on there. It's like, it's the x-axis and y-axis.
Oh, okay. So you actually have a graph that has to do with her movement going up and down. Is that right?
Yes. Yeah.
Okay, let's see if we can figure out. I'm going to move to another screen and give me that graph. And so let's see if you can describe that graph to me.
Okay.
Is it
So-
just horizontal and a vertical?
Yes.
And it's all positive, right?
Yes.
Okay, so what does it start? Are there labels on your graph? What's the label on the bottom?
On the bottom, it says -1, -2, -3, -4, -5, and -6.
Oh, okay, so it does have negatives to the left,
Yes, left and down.
and there's negatives going down also?
Yeah, it's just up to -6, though.
Okay, so let's see if we can see what this looks like. Okay, so we're going to have a graph. I'll just make my graph like this. And you said it's going to go to negative what?
-6.
Negative 6 on the horizontal?
Yes.
Okay, so negative, and then how much down?
Down, it's -6, up to -6.
2, 3, 4, 5, 6, okay. And then how about in the positive horizontal?
The positive horizontal is up to 13.
13, huh?
Mm-hmm.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, there's 10, 11, 12, 13. Okay, and how much going up?
And going up is still 6.
Just 6? Okay, 1, 2, 3, 4, 5, 6. All right, so now what does the graph look like that they give you for this problem?
It says that the y-axis is the feet, and then the x-axis is the time, which is second.
Oh, okay. All right, so I drew a picture of the actual slide, and they gave you a graph of graphing her movement time versus the distance, right? So what's the
Yeah.
graph look like?
Wait, what do you mean again?
Do you have a graph on here?
I drew like a,
But does the problem give you, in the graph, does it give you a line to use?
no, it doesn't have a line inside of it. It's all plain. It doesn't have anything inside of it.
So, I mean, the graph that they give you that on this time and feet, they don't give you a graph to use?
No.
Okay, so they want you to graph this from the information that you have?
Yeah, it says that it graphs the following situation.
Graph the following situation. Okay. All right, so let's look at the following situation. And it said at 2 seconds she goes up 5 feet, right?
Yeah.
So she's going to start here, and after 2 seconds, 2 seconds, she's going to go up 1, 2, 3, 4, 5 feet. Is that right?
Yeah.
So it looks like right here.
Yeah.
So it looks like there's her time versus feet here, right?
Yeah.
So there's our first. She climbs up at a. Does it say she's climbing at a steady rate?
It says that for 2 seconds, she sits for 2 seconds at the top of the slide, and then slides 8 feet down the slide into the water in 2 seconds.
Okay. So she goes up 5 feet, and then goes down 8.
Yeah, she goes. She slides down into the water 8 feet, like 8 feet.
Okay, so I'm going to think, I thought the slide was going to be 8 feet long, but it sounds like she's going to go vertically down 8 feet, right? Down into the water. So
Yeah.
after so here's 2 seconds. In 2 more seconds, she's going to go from up here at 5, and she's going to go down 1, 2, 3, 4, 5, 6, 7, 8, right?
Mhm.
Down here at -3. So 2 more seconds, she's going to be down here. Is that right?
Yes.
So it looks like here's her sliding down.
Okay.
Okay?
So, yeah.
Now what?
And it took her 2 seconds to go down.
2 seconds ago. Right, so there's my 2 seconds from 2 to 4, right?
Mhm.
From 0 to 2 was her going up. From 2 to 4, that's her going down, and she went down 8. Okay, now what?
It says she stayed at the same position underwater for 2 seconds.
2 seconds.
Before-
So let's do that. So 2 more seconds is going to be 6, right?
Yeah.
Now what?
And before rising to the surface of water in 1 second.
So after 1 more second, that's going to be a 7. She's going to be at the surface of the water, which is going to be 0, isn't it? Right? She started at ground level. She went up 5, then she went down 8. Now she's going to go back up 2 in 1 second, right?
Mhm. And she remained in the pool for 1 more second.
1 more second, that's going to get her to 8 seconds. How's that? Okay, so I'm sorry, I thought we were going to draw a picture of the slide in the pool. We're drawing a picture of her motion in terms of time and feet, right?
Mhm.
All right, so here's what the graph should look like. Do you see this graph?
Yes.
Start at 0, in 2 seconds go up 5, in 2 seconds go down 8, that gives me 4 seconds. Then for 2 seconds, stay on the bottom, or stay in the pool, I guess, down at the bottom. You can hold your breath for 2 seconds, right? And then go up to the surface in 1 second, that gets us to 7. And then stay at the surface for 1 second, that gives us to 8 seconds. How's that?
Yes.
Okay, now I think we have a picture of what this problem should look like.
Mhm.
Now let's see if we can answer those questions using this picture instead of the one that I was trying to use. Again, our first question was average rate of change up the ladder,
Mhm.
right? So the
Yeah.
rate of change is feet per second. So it's going to be the same thing. The rate of change going up the ladder is 5 feet in 2 seconds. And it's the average rate of change because maybe she didn't climb at the same rate every step. Maybe she slowed down or sped up. But her average rate is going to be 5 feet of that ladder in 2 seconds. And so the answer we got is still 2.5 feet per second. That's the rate of change. She changed 2.5 feet for every second she was on the ladder, okay?
Okay.
All right, now let's look at B. I think that's going to make more sense with this. At what interval of time is the slope negative? So let's look at our graph. Where is the slope negative in our graph?
It was negative when she went down, so isn't that -8?
Yeah, so they want the interval of time, right? At what interval of time is the slope negative? So the interval is going to be from what time to what time is she going down?
So she's going from 2 seconds
to
2 seconds.
So 2 seconds, and 2 more seconds, that gets us to 4, doesn't it?
Yeah.
So the interval of time is from 2 seconds to 4 seconds, and that's a total time of 2 seconds, isn't it?
Yeah.
So the interval is from 2 to 4. I'm not quite sure what question that they want you to answer. The interval is from 2 to 4, and it's 2 seconds long, isn't it? All right?
So total is 2 seconds long?
The total amount of time is 2 seconds. But if they wanted the interval, sometimes that means where do you start and where do you end, okay?
Okay.
So the interval might be start at 2 seconds and end at 4 seconds.
Okay.
All right? And finally, what's C?
Determine when the slope is 0.
And when is the slope 0?
When it goes back to the start.
Well, let's
Like
see.
when-
Slope of 0 is when nothing's happening, right? She's not going up or down. She's like at the bottom of the pool. So the slope is 0 from 4 to 6 seconds, right? From 4
Yes.
seconds to 6 seconds. That's when she's staying there in the pool before she comes up to the top. And then, again, right here from 7 to 8, isn't it?
7 to 8, yes.
So she stays in the pool for 2 seconds from 4 to 6, and then she stays on the surface of the pool from 7 to 8 and doesn't go up or down, does she?
No.
She stays right there in the pool. So I would say from, again, if I'm going to give an interval, it says, when is the slope 0? The slope is 0 from 4 to 6, from 4 to 6 seconds, right? And also from 7 to 8, isn't it? How's that? So I think that answers all of your questions. There's not much to calculate, but they wanted you to interpret the graph. You understand? When is she going up? When is she going down? When is she not doing anything? Just sitting there, right? Not going up or down. All right? There's your question. Thanks a lot for the call.
All right, Cushy, you
you.
still online with us? All right, well, you know what? Since that was such a great problem to work on, we're going to send you a certificate good for a meal at our friends at Johnny Rocket. So congratulations on that. Thanks for that break phone call. 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio with us right now, our first special guest of the afternoon, Fred Webster.
Hi.
How
Good
are
to
you?
be here. Great.
Now, you're a pilot.
I am, yes.
You're a
from
pilot with what airline?
American Airlines.
American Airlines. And are you, because some kids are like, all right, well, you're a pilot, but you've got things on your shoulders. What does that signify? So is there a certain type of pilot you are, or how can you tell the kids kind of like what you do?
Yeah, the plane I fly is a 737-800. So there's 2 pilots. I'm the captain. So 4 stripes.
Okay.
The first officer has 3 stripes. So that's the difference in the designation.
So as the captain, are you flying the plane more, or is the other person flying
That's a
the plane?
great question. Everyone always asks that. They always think that only the captain flies the airplane. We actually switch off each leg. So the captain will fly one leg, the first officer will fly the second leg. So we have duties of the pilot flying and the pilot monitoring. It's divided, there's certain things that the captain only does, like taxi the airplane and so forth, taxi it
Okay.
in and taxi it out. So
And how long have you been a pilot?
I started flying for the airlines in 1986. I took flying lessons in 1982. So I basically
So you
instructed.
started flying in '82, a couple of years of that, and then you became a professional pilot.
That's correct, yeah.
And how long, I mean, has it always been a goal to be captain, or is it something that's like, all right, it kind of went along and boom, I'm here now?
It's always a goal.
Okay.
Yeah, it's a responsibility add, a pay bump, and everyone likes to be the king, so
Right, I want to be the captain.
that's it.
All right. Well, you know what? You brought some paperwork with you, and if you can just talk a little bit about this, because we want to know how a pilot needs to use math. Because, all right, yeah, you're flying people around, you've got a lot of responsibility, but there's a lot of math behind this.
Absolutely, yeah. So the first graph that we have up this is a landing performance chart. So we have to do some interpolation. So in this example, if we we're going to be landing at an airport, and the top of the graph shows SL, that stands for sea level, 1,000 and 2,000. And let's say we're landing at an airport that's 1,500 feet above sea level. So we're going to be between a 1,000 and 2,000 graph.
Okay.
So now we're going to have to interpolate. In this example, if we're landing on a 4,200 foot runway, which is pretty short, we could land between 107,800 pounds or down to 104.7. So we'd have to interpolate between those 2 numbers.
So the kids get an idea. You said 4,200 is pretty short. What's the one at Meadows Field that students might be more familiar with?
That's going to be around 8,000 feet long, so
Okay.
quite a bit longer. So
So that's about 8,000. What about the municipal airport in town, the one by Union?
that is 4,000 feet long.
Okay, so that's right at
Right, and we wouldn't
This
be
limit
landing
right
a big
here.
737 at that runway. So
Okay.
we'd get a lot of attention if we did that.
All right, so let's take a look at another one that you've got here. And I may need to zoom out a little bit so we can see some more of this.
And what we're using this is actually a weight and balance for a 172, a little four-seater airplane. I also instruct in small airplanes.
Okay.
And this is, how we use math in small airplanes as well. So we have to calculate if the airplane can be flown within the limits of weight and balance. So not only overweight, but not too much weight in the front part or too much in the aft part of the airplane.
Now, when you're flying 737s, what kinds of things do you need to do, like on the spot? Are there calculations that you're constantly doing while you're in the air?
Absolutely. So we're always checking our fuel load and our time, because time and fuel go together. So the longer we're in the air, the more fuel we burn. So if we get rerouted, say around weather or for traffic, we have to recalculate out, do we have enough fuel to land or do we have to land short? They always give us extra fuel, but if there's weather, thunderstorms, and we're holding, that it's very fluid, so it changes. So we're always constantly doing the math to make sure that we have enough fuel to get to our destination.
How often, or have you ever been in a situation where you're like, all right, things didn't work out kind of the way we thought they were going to?
As far as fuel and
Right, things like that.
Yeah, I've gone to Chicago. All the runways are closed because of weather, so then we land. I've landed in Minneapolis before, Rockford before, to get fuel. So
Okay, so you just stop there,
yeah,
and then you fuel up, and then you're back on the road.
That's
Well,
it.
Back on the road, back in
Back
the
on the
sky,
road,
and
yeah.
back in to the new strip in Chicago.
Yeah.
Is there a route that you do more often than others? I mean, as a pilot, do you go, all right, I'd like to do this, go from LA to Chicago, let's say?
Well, I know you're from New York, so if you were a pilot, you'd be wanting to go to New York all the time,
Okay.
probably. So I grew up in Chicago, so I like to go back to Chicago to visit family and friends. So, and it's a complex airport to go in and out of, one of the busiest airports in the world. So it's challenging and rewarding at the same time.
Now, if a student, let's say they're in whatever level, elementary school, junior high, high school, if they thought, being a pilot might be pretty cool, what are some of the things that they need to kind of focus on while they're going through school as far as the math goes? Are there any areas where it's like, you need to really make sure that you're really good in this?
I can't think of one thing other
Okay.
than, I was always interested in math in grade school, so I did well in math, so maybe that's what brought me into flying. It was just solving problems, and that's what aviation's all about. So.
Okay. How long, let's say a student is getting out of high school and they're like, I'd like to become a pilot. Average, how long would it take? Because you said that you started flying in '82 and then you became a pilot in '86. But I'm sure it is different based on how long you can train, things like that. But if a kid wanted to go to school to become a pilot, let's say,
Yeah,
is it the same as for anything
you
else?
could go to aviation-related college and get a 4-year degree and learn how to fly in that 4-year time. Or you could just go to the local airport, like at Meadows Airport, and take flying lessons. That's how I did it. And I actually got my license in less time than I got my driver's license. It took about 2.5 months, but I was
Okay.
flying 3 or 4 times a week to get my license, so
So when you're young, you're flying before you're driving.
yes.
You know what? That's pretty cool too, because I know there are a lot of young adults that do that as well. Because before they're driving, I know in Kern County, there's a lot of students, it seems like, that are flying before
Absolutely, yeah.
they're driving and things like that. What's the next step for you? So you're a captain, and you've been flying professionally since 1986, so you've been doing it for a long time. Is there another step, or you kind of like, I'm a captain and this is where I'm going to be for now?
That's pretty much it. Getting into bigger airplanes. What I work now is for American Airlines. I'm actually what's called a check airman, so I train new pilots.
Okay,
I
so
work in the
that's
training department.
something
So,
new, right?
Yeah.
Because that has come about pretty recently.
Less than a year. In May, I got this new position. So now I go down to Dallas, where American's headquarters is for our training facility. So I train the pilots in the simulator, both new pilots that got hired off the street and pilots that are transitioning from different airplanes or upgrading the captain. So I do all the training down there.
Okay.
Usually rotate for a month, and then I spend a month doing line training out of Los Angeles,
And
LAX.
obviously you must like that.
I love it, yeah.
Otherwise you'd be like, I don't want to do that anymore.
Yeah, no, it's a great opportunity.
All right, you've got a few more minutes to hang out with us?
Absolutely.
Great, because
yeah.
I want to find out a little bit more about these smaller planes, the smaller airports, and kind of like what you do locally here in Bakersfield.
All right, great.
Before we do that, let's go back to the phones. And a student from Stone Creek, Destiny, how are you today?
Good, how are you?
I'm wonderful myself. Are you in 7th or 8th grade?
8.
8th grade. And were you by chance at Stone Creek where the after-school program when Do the Math was out there?
Actually, I was at Stone Creek, but that was for ACEs.
Oh, okay. Well, you know what? I'm sure we're going to be out there again, and hopefully we can meet you out there sometime. But right now, let's hear the math problem that you're working on.
Okay. So, my problem is find the slope and y-intercept of the line represented by each table.
Okay. And so each line, there's a table for each line?
Yeah, it's x over y, and on the x line, it's 2, 4, 6, and 8.
Okay, so do you have a table? Does your table go up and down or across?
It's a cross.
Okay, so I'll make it look like yours. So you're going to have a table like this, and you're going to have x and y, right?
Yeah.
Like this. And so give me the numbers again.
It's x and over y, and on the x table, on the x side, it's 2, 4, 6, 8.
2, 4, 6, and 8. Okay. And the y?
And y is 22, 32, 42, and 52.
All right. So this is one of the problems that you had for one of the lines. Okay.
Okay.
Did you have more than one table?
No, that was the table.
Okay, so for this line, they give you an x value and a y value. Let me get this back. They give you an x value and a y value for each. These are each points, right? So
Yeah.
you didn't have to graph this. You just had to find the slope. Is that right?
Yeah, and though I have to find the y-intercept by just using the table.
Okay. So we're going to do this using an equation. And you're going to use the slope-intercept form. Is that what you said?
Yeah.
So do you remember what the slope-intercept form of an equation looks like?
Slope-intercept form is y equals mx plus b.
mx plus b. All right, so to use the slope-intercept form, we have to find two numbers, right? We know we're going to have in our answer, you're going to have y equals some number times x plus some number, right?
Mm-hmm.
So you have to find the y-intercept, that's b. That's b.
Yeah.
Let me put this. Here's the y-intercept, and you've got to find the slope, and that's going to be m, isn't it?
Yeah.
M for slope. Never figured that one out. Huh? Why does m stand for slope? All right, so let's see which one we want to find. Does it say which one to find first?
No.
All right, so which one do you want to find first?
Well, let's try the first one.
Let's find slope. Okay, m. So how do you find the slope of a line?
The slope of a line.
Do you have any equation or a formula for the equation for the slope of a line?
To find slope, it's m equals y over x, I think. No,
Yeah.
wait, no.
It is y over x, but it's not just y over x. It's the change in y over the change in x, isn't it?
Yeah, the rate of change.
The rate of change. So we're going to do the change in y over the change in x. Do you remember what the formula is? How do you find the change in y?
X sub 1 minus x sub 2.
And
Y
that's
sub
going to
2
go
minus-
on the bottom, right? So
Yeah.
we're going to take x2 minus x1. I think we do x2 minus x1 on the bottom, and on the top you said y2 minus y1, right?
Yeah.
Now all of these points are on the same line, so does it matter which point we use?
No.
It doesn't, does it? So
No.
let's pick 2 points. We can pick any 2 points. And usually, instead of the chart like this, we'll use x comma y, right? So I'll use the point 2 comma 22, and how about 4 comma 32, right?
Yes.
So if you're going to plot them, you'd go x comma y, wouldn't you?
Yes.
All right, so let's do the subtracting. I'm going to subtract the y's. I'm going to go y2 minus y1. That's going to be 32 minus 22, isn't it?
Yes.
And what goes on the bottom is x2 minus x1. That's going to be 4 minus 2.
Yes.
Right? So what do we get?
You get 4 minus 2, you get 2.
That's
and
on the bottom.
Yeah, and 32 minus 22 is 10.
I'm sorry, I wrote 33, but it is 32. Thank you. And that's going to be 10, isn't it? So we
Yeah.
know that the slope is going to be 10 divided by 2, which is? What's 10 divided by 2?
10 divided by 2 is 2.
Again? What's 10 divided by 2? What's
5.
half of 10 is 5. So we know that m is 5, don't we?
Yes.
So all we know now is, instead of y equals mx plus b, we know that m is 5, so we know it's 5x plus b, don't we?
Yes.
So we've got the slope. All we have to do now is find the y-intercept. Okay, now how do we find the y-intercept without graphing? Well, we're going to use these points, aren't we? We know that these points are on that line, don't we?
Yes.
That means that these numbers have to work in that equation, don't they?
Yes.
All right? Now again, doesn't matter which point we use, we know that all of these points have to be on that line. So let's pick the easiest point, the smallest one, right? How about 2 comma 22?
Yes.
This point has to be on that line, so if I put these numbers into that equation, it has to work, doesn't it?
Yes.
So let's do that. Let's put these numbers into that equation. I'm going to get y, which is 22, is going to equal 5 times what's x?
X is 2.
X is 2, plus, well, we still don't know what b is though, do we?
No.
But the nice thing is, that's the only thing we don't know, isn't it? We know
Yes.
everything else in that equation except for b, so all we have to do is figure out what b is. Let's do that.
Okay.
22 equals 10 plus b, right? And let's subtract 10 from both sides. And what's b equal?
Subtract what from what side?
We're going to subtract 10 to solve this equation, right? 22 equals 10 plus b. We subtract 10 from both sides and we get b equals, what's 22 minus 10?
22 minus 10 is 12.
12. So it looks like, I'll come back up here and I'm going to replace b with 12. So my equation in slope-intercept form is y equals 5x plus 12. 5 is the slope, 12 is the y-intercept. Okay?
Okay.
There's your answer. Thanks for the
Nicely
call.
done. Great phone call right there. We do have phone tutors available until 5:30. 636-4357 is that phone number. Fred Webster, an American airline pilot and local flight instructor.
Yes.
So where do you work out of here in town?
Out of the Bakersfield Airport, out of the Bakersfield Flying Club.
So the Bakersfield Flying Club has been around for how long?
About 6 years now.
Okay. And about how many members do you guys have?
Over 100.
So over 100 in 6 years is pretty significant because
very impressive.
I remember, I think Mickey started flying probably kind of like when you guys got started.
Absolutely. We probably had 15 or 20 members.
Yeah, I remember having to pull the plane in and out of the hangar and stuff like that, and now it's delivered.
That's it. Fueled and delivered. That's
Yeah,
great.
that's a beautiful thing. How many, well, let's take a look at what you've got right here first.
Yeah.
All right.
So talking about math, and what this is, now we're planning out a cross-country trip. So this,
So explain, first of all, what a cross-country trip is, because there are a lot of students thinking you're going from here to New York.
that could be a cross-country trip, but in a
big one.
smaller plane, a cross-country trip is more than 50 nautical miles.
Okay.
So Bakersfield to say Fresno. So we plan out that trip. We do all the performance. Again, remember the weight and balance, we did that.
Right.
Then we're going to figure out how much runway we need to take off, how much runway we're going to need to land, how much fuel we're going to burn. And all these calculations go in effect with the winds at altitude, so we have to figure that out because that'll affect how fast we move across the ground. So if we're going into a 20-knot headwind, we're going to be going 20 knots slower, take us longer, but when we turn around and come back the other way, now we're going to be going, faster with that 20-knot tailwind. So all that's calculated in, and each time we pick points along our route of flight so that we could make sure that we're running on time, because again, time is fuel, to make sure that we have enough fuel.
So as you're going through this cross-country trip, when you hit a certain point, you should have that much fuel left based on your calculations before you took off.
Correct, because we know.
But things might change as you're flying.
Right, so if we were supposed to get to the first point 20 minutes into the flight, but it took us 25 minutes, we're going to burn 5 minutes more fuel. So
Okay.
we calculate, depending on kind of which airplane it is, maybe 8 to 10 gallons of fuel per hour. So now we're going to have to make sure that we have extra fuel, or it could be vice versa, where we're going to be over our landing weight if we didn't burn enough fuel.
Okay.
So all those calculations are fluid and are changing all the time.
And that's what I wanted to get across for the kids right
Yeah.
there is that, okay, you can plan everything out, but you've got to be able to think and act and kind of adjust.
The numbers are
fly.
changing, absolutely, on the fly.
Yeah. Now, I know we've kept you here a little longer than we had originally planned. If somebody wanted to find out more about flying here in Bakersfield and get a hold of the Bakersfield Flying Club, how can they do that?
Yeah, we have a website at www.bakersfieldflyingclub.com, or they could email us at bakersfieldflyingclub@gmail.com.
Okay, so basically just Bakersfield Flying Club.
Yep.
And there's an event coming up that you guys are participating in, and I know there's events going on throughout the year, but
Yeah.
what's the one coming up?
Yeah, we have air traffic controllers that are going to be coming to talk at the Flying Club, and I don't have the date in front of me. It is on our website.
Okay.
I believe it's the 11th or 12th of February. And if they want to attend that, please send us an email so we can make sure that we have enough seats set up. But there's no charge, and it's the controllers from the Bakersfield Control Tower. They're going to come and talk to the pilots.
So as the pilots are flying, they're talking to people in the tower. These are the people that they're going to meet.
Yep, absolutely. Yeah.
And that's kind of a frantic position at times, isn't it?
It would be stressful. I don't think I could do that. So.
Well, I'm sure you've got enough things going on as captain with American Airlines right there.
Yeah.
Fred, we certainly do appreciate you taking out some time to come visit us and let us know
Absolutely.
how pilots use a little bit of math in their day. We'll be back with more right after this. Well, today we're in beautiful Lake Isabella. We're visiting Wallace Middle School, and today we're here to Once again, we're at Wallace Middle School, and with us today we've got 6th grader Colton. How are you today?
Good.
Dressed for the occasion, I see.
Yeah.
Well, we're here on Halloween Day, right? So that's why you guys are a little bit dressed up this afternoon. Let's take a look at the problem that you're working on.
Okay.
Why don't you go ahead and read that for me, please?
Okay. 5.6 multiplied by 2.115.
Okay. This one might be a little more difficult. Read this instead of saying 5.6. Is there another way to say that?
5 6/10.
Very good. All right, so we're going to multiply this. You want to try that one?
Okay.
Tenths, hundredths.
Okay. 2 and 115 thousandths.
Perfect. Nicely done. So
Okay.
how are we going to go ahead and do this?
Okay, so how I would start this is I would take this number and put it under this number. Okay. And now
Is there a difference if you do this number on top, or which would be easier?
actually,
Here, let me get the eraser for you quickly here. All right, so you want to get rid of that? You want to get rid of this?
yeah.
Okay.
So I'm going to put this number on top, and then this number.
And instead of lining up the decimals, it might be easier just to line up the digits.
Yeah.
And then we'll take care of the decimals in a little while. All right?
Okay.
So as you're multiplying these, if you could explain what numbers you're multiplying, what you're getting, and then your process of doing this.
Okay. So first I will do 6 times 5, and that equals 30. So I put the 3 up here.
Okay.
And then 6 times 1 equals 6, and then you do plus 3 because you have the 3 up here.
Mm-hmm.
So that would be 9. And then 6 times 1 is still 6.
Right.
And then 6 times 2 is 12.
Good. All right, so what
Now-
we'll do, let's just move the 12 over a little bit so that we keep our numbers close together like that.
Okay.
All right, so we've got 12690. All right.
Yes.
And let's go ahead, because we've used that 3. All right, what's the next step?
Okay. Now you put a placeholder here, which is a 0,
Why do we put a placeholder there? Do you know why?
because now this is in the tens place. If you're ignoring that decimal,
Right.
this is in the tens place and this is in the ones place.
Good. So we're going to start multiplying, and the answers are going to come down underneath here. So
Yes.
that's why you need a placeholder. Okay.
So now 5 times 5 is 25, and I put the 2 up here. And then 5 times 1 is 5, plus 2 equals 7. And then 5 times 1 is 5. And then 5 times 2 equals 10. Now what we do is we add these together, these two numbers.
Okay.
So 0 plus 0 equals 0. 9 plus 5 equals 14. 6 plus 7 plus 1 equals 14.
Good.
2 plus 5 plus 1 equals 7. Wait, 8, I mean.
There you go.
8. And then 1 plus 0 equals 1. And 1.
Okay, so large.
Now-
Let's go ahead and write that number a little larger over
Okay.
here.
Okay. Now, since there was decimals here, we have to put the decimal in here. So what we do is there's 4 numbers behind decimals on this.
Okay, so how did you get
So-
4? Because some students might be doing this for the first time, and they're like,
Okay.
why are you getting 4?
So here there is 1 number behind the decimal,
Okay,
and here there is 3 numbers behind the decimal.
right. So you
So-
just
yeah.
add them all together, right? Okay,
Yes.
you've already got this.
So then you move it over 1, 2, 3, 4 spaces. So the decimal would go there. So your final answer is 11 and 8,440 10,000ths.
Right. And
Yeah.
instead of doing it like, because what we could do is, so we have the proper number of digits there,
Mm-hmm.
all right? So 844 10,000ths. Let's say
Yeah.
the 0 was off. How would you
Yeah.
read it then?
So then it would be 11 and 844 thousandths.
Perfect. How about if I did this to you?
Okay.
Because the decimal's here now.
Yeah.
I could add a lot of zeros here, right? And it's not going
Yeah,
to change the value of the number, but it could change the value of how you read it, right?
Yeah.
You know how to read that one? I'm only kidding. I just put a bunch of zeros on there and messed with you. Anyway, Colton, nicely done.
Okay.
Perfect
Thank
work.
you.
Oh, welcome back. And in studio with us now, we have Samantha. How are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Bill L. Williams Elementary and I'm in the 6th grade.
Home of the Pioneers, correct?
Yes.
All right. Well, you know what? I know that you're working on some equations, and we're going to try to get 2 of them done if we can. So let's get right to the board and work on the longer one first. All right? So as you're going through it, kind of explain what you're doing, and you've got Chuck right there to help you out.
Okay, so what side do you want to start on?
This side.
Okay, so we got to get rid of the parentheses, right? So what do you have on the right side?
3 multiplied by 3. Then right here, look at 3x.
Okay? Now let's go on the right side. What are you going to do first on the right side?
3 by x.
Right, so get rid of this first parentheses. Well, just rewrite it down below, right?
Okay.
Okay, so don't forget we got a plus sign here because it's going to be 3 plus 3x on the left side. And over there we've got a 3 plus 6, right? 3x plus 6. Now, what are we going to do with the minus sign?
Put a 1 before it.
Okay? So what happens when you rewrite that?
It will be negative 1x.
And?
And then it would be
Okay, so we've got 3x plus 6 and minus x minus 1.
yeah.
Now this is all in these brackets, right? And we still have this 2 out there. So let's stay inside the brackets. Can you simplify what's inside the brackets now?
Yes.
So you're going to take that 6 and the -1, right?
Yes.
And what do you get?
5.
Okay, and then what about the 3x and the -1x?
You can get the 2x.
All right, so we're going to have a 2x, and is that a +5 or a -5?
Plus.
Right, so now those are inside the brackets, aren't they?
Yeah.
So let's put brackets around that 2x plus 5 and around the other side. And what's still out in front?
And here you still have.
We still got this 2, don't we? So let's put that 2 right there. And now how do you get rid of those brackets? So you remember what property we're using here?
Yes. Multiplication.
Yes, so we're multiplying by the 2. And what we're doing is we're distributing that 2, aren't we?
Yeah.
So we're using the distributive property to do this. Okay? Right? So on the right side, you've got 4x plus 10, don't you?
Yes.
And then let's put our equal sign, and let's go ahead and put down what we had over here. We didn't take very long to get that 3 plus 3x, did it?
Yeah.
So it looks like you simplified everything on the left side and simplified everything on the right side. Now that you've got this, how do you get those x's together?
You subtract 3x, then you have to do the same to the other side.
Do the same thing to the other side, all right? So what do we get here?
X plus
Equals, and what's on the other side?
3.
Yeah, because what happens to the 3x and the -3x?
It gets canceled out.
All right, good. All right, so we're almost done, right? You've almost got x by itself. What's the last thing you have to do to get x by itself?
To get rid of the 3.
Well, let's see. We want to get the x by itself.
And I'll
So
give you
let's-
30
Get rid of
seconds
10.
to wrap
So
it.
let's get rid of that 10, right? And so it looks like -7 equals x, and that looks like it should be our answer. Now, with
There you
more
go.
time, Mr. Kushine, we would take time to check it, but it looks like our answer is going to be -7.
There you go, nicely done. Samantha, come on back over here real quick. And you're in 6th grade, and one of the big things that you'll be doing is going to Camp Keep at some point during this year.
Yes.
Have you heard about this coming up at all?
Yes.
What do you think will be the best thing about going to Camp Keep?
I don't know.
You don't? Well, you know what? I know you probably, have you started studying about it yet in class?
No.
Okay, because you're probably going to be going in the spring then, right?
Yes.
Okay. Well, I can guarantee you this. All the students that go to Camp Keep, when they think back about their 6th grade year, the biggest thing they remember is going to Camp Keep. So I certainly hope you have a great time. Certainly do appreciate you taking out time to come here and spend some time with us. Chuck, why don't you find out who's going to see the Condors?
All right. And we have Destiny from Stone Creek Junior High.
All right, there you go. Nicely done. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.